Let's do lesson 8 and 5/10 line plots, 1/2, 1/4, and 1/8 inch. Woohoo! Why, oh, why are we doing this lesson? Well, we need to be able to make line plots. We need to be able to add and subtract mixed numbers to answer problems, and we need to be able to measure to the nearest 1/2, 1/4, and 1/8 inch. So lucky for you, the how today, I have already measured these for us. So let's say that I have these line segments and I already measured them like I said. So this set of line segments here, each one of those is 4 1/2 inches long. Each of these line segments are 1 3/4 inch long, and this lonely little one here at the bottom is 2 1/8 inch long. Now, what you're going to be doing is taking similar line segments in your books today and figuring out the measurements, and then you have to plot them on a line plot. So let's look at how we would do that. So as you take a look at this line plot, you'll notice that when I put my numbers on here, I put my whole numbers in blue, and then I put the halves in green and my fourths in white. And if you will recall, I had a line segment, actually several of them, that were 1 3/4 inches long. And from looking at my line plot, you should see that I have 1, 2, 3, 4, 5 X's above that measurement because there were 5 of those line segments that measured that. I have 1 X here between 2 and 2 1/4. What measurement do you think would be in the middle there? Hopefully you figured it out. It was 2 1/8. And if you will recall, I only had one of those. And then down here at the end, I had to add on to my number line because we had some line segments that were 4 1/2 inches long. In fact, we had 3 of them. So this really isn't anything new other than we've got fractions. And one thing I want to point out is all of these fractions were fairly easy to plot, but you are going to have some that you're going to have to probably convert to equivalent fractions. So let me show you an example. Actually, I'm going to show you 3 examples. So let's say that our data set has 6 1/2, 9 1/4, and 7 1/8. And as you probably noticed, we do not have the same denominator in any of those mixed numbers. So if we were going to plot those in a line plot, it would probably be a lot easier for us to have the same denominator. So below each one of those, what I've decided to do is convert them into eighths because it's just easier. So I took the mixed number 6 1/8 and I changed the denominator to 8, which means what did I multiply this 2 by to get 8? 4. So that meant that I had to multiply the top also times 4. That's how I got 6 4/8, in case you've forgotten how to do that. And then when we take a look at 9 1/4, again, I needed to change the denominator to 8. That means I had to multiply 4 times 2, which gave me this 8, and I had to multiply the 1 times 2, which gave me the 2. So that's how I got 9 2/8. And then lo and behold, our last one we did not have to change because it was already in eighths. So now I would be looking at 6 4/8, 9 2/8, and 7 1/8. Everything is in eighths, and so when I go to put that in a line plot, it's going to be a lot easier to do that. So there you go. You've got a couple of techniques there to kind of help you with your line plotting. In class, we are going to make line plots displaying data to the nearest 1/8 of an inch. And we're going to be working with partners to measure, organize, add, and subtract mixed numbers. Bye for now.